click the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Good day everyone, I hope you're having a great day. Welcome to Smart BUCAD video tutorial on the course Electricity and Magnetism. Today we're having a question on point charges. So here is the question: 2 point-like objects with electric charges Q1 is equal to 0.5 nanocoulomb and Q2 is equal to minus 0.3 nanocoulomb are separated by a distance 0.5 meter. How much work is required to transport a third charge Q3, which is equal to 0.2 nanocoulomb, from infinitely far away to a position exactly at the midpoint of the line connecting the two other charges? So this is a tricky question. Don't be fooled by the English. So let's quickly solve the question. Basically what we are asked to do is just to find the work done, the work required to move Q3 to the midpoint. So we are told that we have two charges Q1, so let's call this Q1. So we are having another charge here Q2. They are like charges, so one is positive and the other is negative. So Q1 is the one that is positive and the other one is negative. So definitely these two charges, they will attract. So we are told that there's a distance between them which is 0.4. so the total distance between them is 0.4. So we can separate this distance to the midpoint. So the midpoint, now we are going to have 0.2 here, and the other one will be 0.2 also to the midpoint. The distance Q1 to the midpoint and Q2 to the midpoint is 0.2, 0.2. Just dividing the total distance by 2. So to find the work done, the work required, we know that W is equal to PD multiplied by Q. We have been solving questions on work. So for us to get the work required, we are going to find the potential difference from Q1 and Q2. Then we'll multiply it by Q3. We've gotten the work required. So to find this potential difference is the same thing as V, and it is given by a formula which says that Q1, if you are finding V of two charges, you can say is equal to V1 all over 4 pi permittivity of a free space R plus Q2 all over 4 pi epsilon naught R. So we're having our Q1. Our Q1 from the question is being given. So our Q1 from the question is given as 0.5 nanocoulomb, 0.5. So nanocoulomb is times 10 raised to the power of minus 9. Q2 is given as minus 0.3 times 10 raised to the power of minus 9 nanocoulomb also, and Q2 and Q3, the last charge, is given as 0.2. so Q3 is given as 0.2 times nanocoulomb also. So we can quickly slot in our parameters and get voltage. So the voltage is equal to Q1, we are having 0.5 times 10 raised to the power of minus 9 all over 4 pi epsilon naught R. Our R, I told you, is the distance. This place is R and this place is also R. So we are having 0.2 plus, so Q2 is minus 0.3, so minus 0.3 all over, we are having 4 pi epsilon naught open bracket 0.2. so this is what we are having. So we can quickly, this and this is the same for the two. We can quickly factor it out. We can say V is equal to here we are also having times 10 raised to the power of minus 9. Don't forget the nanocoulomb. So we can factor out 10 times 10 raised to the power of minus 9 divided by 4 pi epsilon naught, since it's the same for both. So we're having 10 times 10 raised to the power of minus 9 all over 4 pi epsilon naught 0.2, since it's the same thing for both. Then we are having open bracket 0.5 minus 0.3. so it is not compulsory you follow my method, you can follow yours. It's the same thing, is mathematics. You can quickly get your answer. So this, we are having 10 raised to the power of minus 9 all over 4 pi epsilon naught open bracket 0.2 multiplied by 0.2. so this 0.2 can cancel 0.2. so this 1 over 4 pi epsilon naught is the same thing as 9 times 10 raised to the power of 9. It's the same thing as 9 times 10 raised to the power of 9. So it's the same thing, because epsilon naught is 8.85 times 10 raised to the power of minus 12. So you can quickly slot in and get your answer. So this is, instead of putting epsilon naught, you can just put 10 raised to the power of minus 9 multiply by 1 over 4 pi epsilon I send is 9 times 10 raised to the power of 9. So this is equal to 9 times 10 raised to the power of 9 minus 9. So this is 0. So we are having V is equal to 9 volts, and this V is the same thing as potential difference, which is the same thing as 9 volts. So quickly now we can find the work required to move the charge to the middle, which is work is equal to PD multiplied by Q3, since we are looking for the work required to move charge Q3, and Q3 is given as 0.2 nanocoulomb. 0.2 times 10 raised to the power of minus 9. So our work is now equal to 9 times 0.2 times 10 raised to the power of minus 9. So this is equal to, so our work is equal to 1.8 times 10 raised to the power of 9 joule. So this is our final answer. This is the work required to move Q3 to the midpoint of the two charges. So I hope you understand this tutorial. If you are enjoying what we are doing, please don't forget to subscribe to our YouTube channel for more subsequent videos. Thank you very much for watching this video. We'll meet in our next tutorial.